Hello, my name is Mirja Agarwal, and I'm working in Rajiv Ram's Physical Optics and Electronics lab for my super year op this year. I'm a TI Innovation Fellow, and this is my project on wearable optical health monitors. The focus of my project is to design a high-power wearable laser that can be used for glucose sensing through the skin. Some of the challenges you meet with trying to design a high-power wearable laser are mainly temperature stability and power stability. So to deal with temperature stability, we're trying to get stable power and wavelength output. If your laser heats up, which it will do if it's not properly cooled, that wavelength will change and the power output will change. So the first focus of my project was trying to decide how can I cool my laser without any active control. So active controls would be like trying to use an active temperature controller or trying to use liquid nitrogen to cool the system. But instead what I'm trying to do is just use passive heat dissipation by designing an optimal heat sink. So to do that, the first thing I did was design an initial prototype just to get a functional prototype made. And so I have the laser diode connected to a laser submount, and that's also connected to the electronics. When I tested this demo, I saw that the power was not very stable over a period of 5 minutes, and that's because the thermal interfaces between all of these pieces was very poor. So in the next iteration, what I did was trying to focus on how can I make those thermal interfaces better. So you want high surface area and really good thermal contact for proper heat dissipation. So to do that, in my second prototype, what I have instead is the laser diode is connected to a tube that focuses the beam into a spot, and that tube is connected directly to the heat sink. So you have lots of surface area that's contacted with the laser and the rest of the thermal mount. So you also have the laser mount directly connected with the rest of the wristband, and that allows heat to flow from the laser to the rest of the wristband and then dissipate into the air. So that's the current prototype, but we're also trying to make it more compact and more efficient and wearable.